Hi, my name is Stacy Joseph, and I want to answer the Euler's problem 474 with an algorithm that I did in Python. So here I'm assuming that the number of digits in the divisor desired is going to be 10 digits or less. And so what I did was I requested from the user the number that needs to be analyzed and the ending of the divisor that is required. So after getting the input and finding out that information, I figured out how many digits is in that number or the ending of the digits. So if I find out how many digits is that, then I can determine whether or not it's divisible, or if it ends in that number. Okay, so then I did a for loop to find out how many digits, and then after that I did another for loop right here that goes from I to the end of the number until and the number, just to find out all the divisors. So I basically did a modulus, a remainder function to find out if the remainder is 0. That means if it's divisible by I, then I'm gonna say then that's a keeper. Go ahead and keep track of that and print it out. And then add, so the tracking is in X. So we increment X by 1. And so we find that, and once we find that factor of the number, then we'll go ahead and determine whether or not we want to track it as one of the divisors that end in a digit. So first we have to basically figure out, okay, is it divisible? Or is it, does it end in that number? So what I did is I subtract the number desired, the ending of the number. I subtract it from that factor and find the modulus depending on how many digits. And then if that is 0, if the remainder is 0, then we'll keep track and increment the number of divisors. If not, it just keeps on going. Alright, so I'm thinking it's pretty simple algorithm. Then in the end it prints out how many divisors end in that digit. So I'll just go through a couple of runs for you. So I did 8415 as one number. I did 7 as the digits, and it says there are 2 divisors that end in 7. Now, just so you can see that where it's figuring out which one is divisible, we're just gonna print this ends in that number. So we'll do that there. I'll rerun it. So I'm just gonna pick some numbers at random, 4215, and I want to see if it ends in, say, 25. Okay, so there's 0 divisors that end in 25. So nothing ends in 25. So that's that. So then if I run it again, I said 95457 I said, does anything end in 26? Nope, nothing ends in 26. Then I have, say, 5, 1, 2, 4, 6, 2, 3, 5. And I want to see what ends in 4, 9, 2, 4, 7. It says this ends in 49247. So the second factor actually ends in 49247. I kind of found this out and it calculated it. It takes a little while for some reason on this problem, but it does eventually get down to 1 and then spits out the fact that there's one divisor that ends in 49247. So the efficiency on this one is not really that good. I'm pretty sure that there might be a way to gain more efficiency on a different type of platform. But anyway, nonetheless, the algorithm works. I think one of the examples in the actual statement of the problem was 84. And I want to see which divisors end in 4. And so we find that there are 3 divisors that end in 4. Okay, so I would call them factors, but you know, either way. So that's pretty much it. If you do have any questions, feel free to leave a comment. You can like or subscribe. You can also visit my website at mendarin.com. That's mendarin.com. And I did leave out a N. mendarin.com. Thanks for watching.